Hello and welcome to our physical sciences session. My name is Temba. Today we are focusing our attention on a very exciting part of chemistry which has to do with reactions that actually take place in an aqueous solution, right? Because in nature there are many reactions that take place, and the medium in which these reactions actually take place is what is of particular interest for us today, right? Okay, so this is under the broader knowledge area of chemical change. So we'll look at solutions, but what exactly makes up a solution? It's a solvent, the substance in which a solute kind of dissolves in that. So if you have a solute and a solvent, you actually get a solution. So if a substance is dissolved in water, it gives us an aqueous type of a solution. So this is what is going to be of interest to us for today, right? Okay. Now, the thought that's going to guide our discussion for today is that have you thought about why do some chemicals actually dissolve in water? All right, because we're talking about these reactions that take place in aqueous solutions. So the big question that we want to kind of arrive, at some kind of understanding is that why do these chemicals actually dissolve in water while some they do not, right? Okay, so some of the terminology that we're going to use today are as follows. We have got the solute, okay, which is actually a substance, a solvent, which is another substance put together, giving us a solution. And then the other term is electronegativity. Speaking of terminology, this taps into our understanding in terms of recalling or remembering some things that we have been taught or we have been learning in the process. So when we talk of definitions, remember, it's either you remember or you don't, okay, because it is about remembering, which is why if a question has to do with defining a concept or a term, the idea is that you need to use the correct or the correct keywords in the correct context. So it's either 2 marks or nothing. In some cases, you'll be given a description and you have to identify the term that fits the description. So we are still defining, it's just that we're doing it backwards, right? So these are some of the terms that are very important in as far as reactions that take place in an aqueous solution. Right, so water is a very important solvent, okay? So if we say that water is a solvent, it means it has the ability to dissolve other substances, or in other words, other substances can actually be dissolved in water to give us what we would refer to as an aqueous solution. So any solution that is formed with water as a solvent is called an aqueous solution. So when we talk of an aqueous solution, it means water is the solvent in that particular solution. Because what is it that we know about a solution? Is that a solution consists of, a homogeneous mixture of a solute and a solvent. And remember, when we talk of a homogeneous mixture, it means if we have a sample of this solution, it means we are not therefore able to distinguish between, the particles that make up the solute and those of the solvent. So that kind of, knowledge needs to come to the fore, right? Okay, so that's very important. Now, the big question again is, why is water such a good solvent? Our bodies consist of a very huge percentage of water. It's also, if you look at many of these reactions, they actually take place in the presence of water. So water is a polar molecule. So there's a very important term that we spoke about in terms of electronegativity, right? So electronegativity is a measure, of the tendency of an atom to attract the bonding pair of electrons. So there is a bond that exists between the oxygen as well as the hydrogen atom in a water molecule. Remember, this model comes from the chemical formula H2O. So it means for every oxygen atom, there are 2 hydrogen atoms bonded, to each other. So there's a bond that exists between oxygen and hydrogen. And also, you need to realize that the oxygen has a greater electronegativity than that of hydrogen. That's why the molecule of water is polar. Why? Because where there's an oxygen atom, there's a slightly negative charge because of the high electronegativity value of oxygen. So the oxygen has a tendency to actually attract this bonding pair more than the hydrogen, which makes the hydrogen to have a slightly positive charge, which we'll refer to as a delta positive charge. Similarly, the other hydrogen atom will also actually show the very same characteristics. That's why water is considered a polar molecule. Why is it a molecule? It is because it is a covalent compound, right? So water is molecular as well as polar. So this is all about in terms of the chemistry of water as a very good solvent, right? Okay, and then also there's a strong electrostatic forces between water molecules. So there are very strong forces between water molecules. We call them intermolecular forces, okay? This means that the water molecule remains a liquid at room temperature. I think part of the reason why water becomes a very ideal, natural habitat, for aquatic animals is because it can stay a liquid, over a very wide range of temperature. That appeals, to the forces that exist actually between the water molecules. Okay, so we are actually relating the knowledge of water as a molecule to that of its application, in real life. Right, so that's very, very important. And then also, these strong electrostatic between the water molecules and particles of other substances result in dissolving. The reason why water is able to dissolve particles, of substances is because of these electrostatic forces that exist between the water. It means the forces that exist between water molecules can actually detach the particles from a crystal lattice if it was a solid. So that's why water is a good solvent, right? And then salts, which are actually solid, most of them at room temperatures, they are ionic substances because they consist of positive as well as negative ions that are pegged in a crystal lattice, okay? So the water molecules, they surround these ions and overcome the forces between these ions. That's why water is able to dissolve many salts. Not all, but many of them, they're actually soluble in water, right? Okay, now this is exactly how we would actually model what exactly happens, at a particle level when a salt dissolves in water. So the salt consists of the sodium cation, which is positive, and the chloride anion, which is negative, right? Now, what are we saying? Around the chloride ion, because of these strong electrophostatic forces between the water molecules, now the chloride cation, which is negative, is actually surrounded by water molecules. But realize that there is a force that exists between the negative chloride anion and these hydrogen ions in the water molecules, which are positive because they are opposite in charge. And then the opposite happens with the cation of sodium. What is surrounding these water molecules are actually these molecules, and you realize that the oxygen is the one that's closer to the cation, yet on the other side is actually the hydrogen part of the water molecule. So this is exactly what happens when a salt dissolves in water. Right. Okay. So in dissolving, you'll have, for argument's sake, an ionic substance like sodium chloride. Now, because water is a very good solvent, sodium chloride is completely soluble in water. Okay. Now it then breaks down into its individual ions. So when a salt dissolves in water, the process is referred to as dissociation. Right. Okay. And then some of the salts, they don't dissolve. We have said that not all salts are actually soluble in water. Okay, these salts that do not dissolve in water, we'll describe them as insoluble salts. Okay, but there are solubility rules that are very important, and these solubility rules actually get to explain to us why some salts are insoluble. It's because the forces between the ions in the insoluble salts are stronger by comparison to those that are present between water molecules. So if the forces in water molecules are weaker than the forces between, the insoluble salt, it means those salts, they cannot dissolve in water. That's the main idea about, the solubility of salt. Right. So these are some of the very important, ideas in as far as some of these reactions that take place in an aqueous solution. Now, we'll take a short break for now, but after the break, we'll look more into detail into the solubility rules, because we've said clearly that there are some salts that are soluble in water, some are insoluble. So we'll try and discuss that further after the break. Let's take a short breather for now.